In last class, we discussed the properties of infinitesimal translation operator. There were 4 properties. In this class, let's take an infinitesimal translation operator in the form of t of dx dash equal to 1 minus k dot dx dash, such that it should satisfy all the 4 properties which we were discussed in last class, where k equal to kx I cap plus ky j cap plus kz k cap, and dx dash equal to dx dash I cap plus dy dash j cap plus dz dash k cap, where the components of this k operator, that is kx, ky and kz, are Hermitian operators. Hermitian operators. We'll define this operator dx dash as dx dash equal to a particular number into an identity operator in some particular direction. This means, let's consider one-dimensional space. Here it's 0, 1, 2, 3, 4, etc. Let the particle be here, and this transform from here to another point to 0.5, another point. So this small distance is 0.5. Whatever this 0.5 represent this number, an identity operator in some particular direction. So this you should keep in your mind while using the operator dx dash. Okay. We have taken translation operator t of dx dash as in this form, 1 minus k dot dx dash. We have to verify whether this translation operator is satisfy all the 4 properties. So we have to verify the first property. First property is t dagger of dx dash into t of dx dash equal to 1. So we have to, first of all, we have to verify the first property, that is t dagger of dx dash into t of dx dash equal to t dagger of dx dash x dash should be 1 plus, sorry, there is an I missed out. So 1 plus I k dagger dot dx dash into 1 minus I k dot dx dash. This is equal to 1 minus I into k dagger minus k dot dx dash plus k dagger dot dx dash into k dot dx dash. Okay. Listen, this last term, this is k dagger dot dx dash into k dot dx dash. This is a scalar product. This is also another scalar product. This term contains dx square term, or dx into dy, or dy dz or dxz terms. Dx or dy or dz, these terms are already too small. So the square of it, when we are taking the square of these terms, this will become too small. So we need to, so we just ignore these values, ignore this term in this derivation, and this also equal to 0 because k dagger minus k, we have mentioned earlier, kx, ky, kz are Hermitian operators. So k dagger equal to k, so we can this k dagger minus k should be equal to 0, and we will get t dagger of dx dash into t of dx dash approximately equal to 1. So we have verified first property. And the second property is t of dx double dash into t of dx dash equal to t of dx dash plus dx double dash. So we will verify the second property. Second property, that is t of dx double dash into t of dx dash x dash into t of dx dash equal to t of dx double dash is 1 minus I k dot dx double dash into 1 minus I k dot dx dash. This is equal to 1 minus I k dot dx double dash minus I k dot dx dash minus k dot dx double dash into k dot dx dash. So this last term contains the terms dx square, dx dy or dx dz, etc. So we can ignore this term because the square of the dx or dy or dz or the multiplication of dx dy will be two small values. So we can ignore this term, and the remaining terms, if we write this equal to 1 minus I k dot dx dash plus dx double dash. That means this is equal to t of d, means this is equal to t of dx dash plus dx double dash. So we have verified the second property too. Next we will verify the third property. The third property is t of minus dx dash equal to t inverse of dx dash. T inverse of dx dash. That is t inverse of dx dash. T inverse of dx dash equal to one divided by 1 minus I k dot dx dash. Okay, this is equal to 1 divided by 1 minus I k dot dx dash into, we are multiplying and dividing and multiplied with 1 plus I k dot dx dash divided by 1 plus I k dot dx dash. So this is equal to 1 plus I k dot dx dash divided by a minus b into a plus b is a square minus b square. A square minus b square, that is minus I k dot dx dash whole square. And this term in the denominator is approximately equal to 1 because this term contains dx dash square, or the denominator is approximately equal to 1. So we will get 1 plus I k dot dx dash. I k dot dx dash. This is equal to t of minus dx dash. So we have verified the third property too. Then the last property, finally fourth property, the fourth property, limit dx dash tends to 0, t of dx dash equal to 1. This is the fourth property. So we are taking the operator, our translation operator is in the form of 1 minus ik dot dx dash. So the term dx dash tends to 0. If dx dash tends to 0, this will be equal to 1. This will be equal to 1. So we have verified that these forms of translation operator out and out satisfy all the four properties. Okay.